Haughton Crater is an impact structure. So what that means is that a rock from space fell into Earth and made a huge hole. Haughton is on Devon Island, which is in the Canadian Arctic. So this big rock impacted 31 million years ago and left this giant hole that we see today. And what makes it such a good Mars analog is that this entire island is frozen because it's in the Arctic. So this is just like Mars. Mars is a cold place covered in impact craters. So we can use Haughton as a Mars analog to study Mars on Earth. The name of the GRAPE mission is actually short for Gamma Rotorcraft for Analog Planetary Environments. And so why we do GRAPE is actually to try to understand how we can use rotorcraft or drones to better understand environments on Mars and beyond. So we planned to take the GRAPE mission concept to Haughton for about 15 days in the Canadian Arctic in July of 2022 to test out some new instrument techniques and measurement techniques that we hope to one day apply to Mars. Getting to Devon Island is not easy. There's a certain point at which you can't take a commercial flight. Once you get to Resolute, which is on Cornwallis Island, you can't take a commercial flight anywhere north, so you have to charter a flight. So we worked with the Canadian government to actually get our entire field team and all of our equipment to Devon Island.
This is where we have our tents. So we've got 17 people staying here, so 17 tents inside of this enclosure. The enclosure is for polar bears. So we have posts arranged all the way around with essentially bear bangers attached to the posts that will trigger if a bear tries to come through the fence at night. It's deactivated during the day. And this is basically so that if a bear tries to come into camp, it not only tries to freak out the bear, but it'll alert us that there is something trying to get into camp and that we should be aware of it.
The goal of the GRAPE mission was to do two things. One, we wanted to compare what it would be like to select sampling sites from the air, if we only had images, to what we would consider the gold standard, which would be geologists on the ground. So we took data in these two different ways. We also wanted to take measurements using a chemistry technique to try to understand how those sites were different. And we were looking for things like the chemistry of life. So to better understand where might we find biosignatures in these samples that we've selected from the air and from the ground.
I'm back here in Neutron Valley with my colleague Anne, who you can see behind me. We got neutron data in this area on a number of rocks that we selected both through a foot traverse and also through drone. And now we're back to get some handheld libs.
What's in there?
A lot of magnesium.
As part of the GRAPE project, we used two different drones that could image from above. So we were able to make maps of the areas where we wanted to sample, and we could also take some really beautiful images. One of the most surprising results that I think we found from GRAPE was just that the sites selected from the drone were actually comparable to what the geologists were picking on the ground. So I think this gives us a lot of confidence that we can use drone-based systems to really do good geology on other planets. The dream goal of GRAPE is to be able to make autonomous drone platforms that can go make measurements on other planets and make decisions about what to do next without having humans making that decision. Doing field work isn't easy, and it also takes a lot of resources. So I feel really lucky that our team was supported by Los Alamos National Laboratory, as well as the Explorers Club and Discovery Incorporated, to be able to gather these data in this unique place on Earth.